Hi Chem Peeps. This is the last video under thermodynamics. We're going to do some sample problems on Gibbs free energy. I've got three problems here that we're going to work on. So let's look at the first problem. It says calculate the free energy changes for the reactions in problem A and B and determine if each reaction would be spontaneous. So you can see here with the you can see the values that they gave me. They gave me the entropy, the enthalpy, and the temperature. So I'm going to be using one of the two reactions. I will not be using products minus reactants. I am going to be using delta G, Gibbs free energy, is equal to the enthalpy, delta H, minus the temperature in Kelvin, times the entropy. Now, I said in my video prior to this that I always multiply by 1 over 1,000 so that I can get the joules in the entropy to be similar to kilojoules with the enthalpy. Okay, so let's go ahead and plug in the values for this problem. So the delta G in problem 1A, the enthalpy is going to be a negative 75.0 kilojoules. The minus the temperature, which is in Kelvin, minus 298 K, times the enthalpy, which is negative 80.7, and it's in joules per mole K. So that's why we need that 1 over 1,000 on the end. Okay, and if I solve this problem, I am going to get a positive 51 kilojoules. Because it's positive, it is going to be non-spontaneous at this temperature. Okay, so let's go to the next problem. Change my color here so it's easy to see. So we're given an equation where we have iron oxide going to a different form of iron oxide and oxygen. Again, they give us the entropy, they give us the temperature, and they give us the enthalpy. So the delta G of this problem is going to equal 235.8 kilojoules, sorry for the messiness, minus the temperature, and it's 298 K, times the entropy, which is 134.2, and that's in joules per K mole K. So that's why we need the multiply by 1 over 1,000 here to get the units to change. So when I simplify this, I am going to get 195.8 kilojoules. This again is going to be non-spontaneous because delta G is positive. Now if we look at the next problem, it tells us, it says, find the minimum temperature above which the reaction in part 1b will become spontaneous. And then there's another question after that, calculate the delta G for this reaction for 1 mole of oxygen. So I'm going to change my color yet again. Let's go to red. So we want a negative value here. So I'm just going to say in this next problem that delta G is going to be negative 1. So when it becomes negative, what will the temperature be? So we're going to solve for temperature. So we have 235.8 kilojoules here, minus the temperature that we don't know to make it spontaneous, times 134.2 joules per mole K, times 1 over 1,000 to convert joules to kilojoules for entropy. So if I simplify this problem, I'm going to first take this one over. So I'm going to have a negative 236.8 equals a negative t times, and if we multiply this, it's going to be 0.1342. So if I solve for t, okay, if I combine and solve for this, our temperature is going to be 1,765 K before delta G becomes spontaneous or negative. That's a pretty high temperature. Now, in this problem, it says calculate delta G for this reaction if 1 mole of oxygen is formed. So let's look back here. We actually have half a mole, and to find out what the delta G for the reaction at 298K would be for 1 mole. We would come down here and take this answer. So the delta G was 195.8 kilojoules, and that was for half a mole. So I'm going to multiply by 2, and that means my new delta G is going to be 391.6 kilojoules for 1 mole of oxygen formed. Okay, so this is Gibbs free energy. Under thermodynamics, you can find other videos for chemistry on TikTok and YouTube at Chem's Chem Chats. I hope this helped, and I'll catch you on the next video.